Hello everyone, I am Shravani and my AAT topic deals with the principles and the applications of thermogravimetric analysis. There are many different instruments that are based on the principle of thermal analysis. One such instrument is the TGA, which is a crucial analytical technique that measures the weight change of a sample as it is heated, cooled, or held at a constant temperature under a controlled atmosphere. So the function of this TGA is to determine the material composition and the thermal stability. The principle of the TGA is that the amount and the rate of mass change of a material with respect to temperature or time in a controlled environment is measured. So the output of the TGA is obtained as a curve called the thermogram. So the scan range of this TGA is from 25 degrees Celsius to 1200 degrees Celsius. So what does the output of TGA give us? So it gives us the thermal stability of materials, the moisture and volatile content, the physical and chemical phenomena, the purity of the sample, and the composition of the multi-component systems, along with the decomposition mechanism of inorganic salts. So the instrument of TGA consists of six main parts. Firstly, the balance, a sample holder, a furnace with temperature programming facility, a temperature sensor, an inert or oxidizing environment provider, and a recorder. So the working goes like this. The sample is heated in a given environment at a controlled temperature rate. The mass of this sample is recorded as a function of either temperature or time. During heating, the sample may either lose mass or gain mass. So the weight loss is caused due to decomposition by breaking of chemical bond or even evaporation by the loss of volatile matter or reduction or desorption. On the contrary, weight gain is caused due to oxidation, which is by the interaction of the sample with an oxidizing atmosphere, or absorption or even adsorption. All of these are kinetic in nature and they occur at different rates. So the main output of the TGA is a thermogram, which is a mass versus temperature plot. There is two main types of thermograms. One is the actual thermogram and the other is a differential thermogram. So the thermogram is a mass versus temperature plot, whereas the differential thermogram is a rate of change of mass versus temperature plot. It can be observed that in the thermogram, the region from A to B is almost horizontal. This is because the sample is thermally stable from this temperature range, and at B, there is a steep decrease observed, which shows that the sample undergoes weight loss at this temperature, after which the mass of the sample becomes stable again. So the best example for a thermogram working can be seen by the thermal decomposition of calcium oxalate monohydrate. So this decomposition occurs in three main steps. So calcium oxalate monohydrate is stable up to 100 degrees Celsius. The removal of water begins at 100 degrees Celsius and it gets finished at 226 degrees Celsius. So there is a horizontal portion observed from 226 degrees Celsius to 346 degrees Celsius, which shows the thermal stability of CaC2O4 in this portion. The decomposition of CaC2O4 to CaCO3 with the elimination of CO occurs in the temperature range of 346 to 420 degrees Celsius. At 420 degrees Celsius to 660 degrees Celsius, the horizontal portion gives the thermal stability of CaCO3. Above 660 degrees Celsius, CaCO3 decomposes to CaO and CO2, after which it becomes stable. So some of the applications of TGA is that it helps us analyze the polymer. It gives the thermal stability and it helps identify the consisting polymers. This can be done through the thermogram itself. The other application is the proximate analysis of coal. wherein the moisture content and the volatile matter are identified through the analysis of the thermogram. However, there are some limitations for a thermogravimetric analysis. So, which are only solid samples can be analyzed, liquid and gaseous samples cannot be analyzed through this method. It can only be used for a material which undergoes mass change with temperature. It cannot study processes such as melting, transitions from one crystalline to another, or even glass transition temperature. All the references to this PPT can be found in the textbook Instrumental Method of Chemical Analysis by Chatwell. I would like to conclude here. Thank you.